Welcome to the walkthrough for Assignment 2, Part B. The objectives of Part B of this assignment are to learn how to synchronize Java threads via a recursive mutex implemented using Java ReentrantLock and a semaphore implemented using a Java ReentrantLock and a Java ConditionObject. Videos describing these relevant Java synchronizers appear on my YouTube channel. Naturally, we'll also cover these topics in class as well, but I recommend you watch these videos first to ensure you understand the Java synchronizers we'll be covering in this part of the assignment. In this part of the assignment, you'll use the semaphore you implement along with the recursive mutex to enhance the executor service thread pool implementation of the Palantir simulator app that you implemented in Assignment 2A. Assignment 2B focuses on the Palantir manager, which, as we've described before, is used to restrict the number of beings from Middle-earth who can concurrently gaze into a fixed number of Palantiri. As always, the Palantir simulator app is packaged as a project using Android Studio version 3.x. For the purposes of Assignment 2B, you only need to be aware of several directories. In addition to the test directories, the unit tests, and the Android tests, you'll also have to take a look at the ReentrantLock hashmap simple semaphore directory, which contains the skeletons that you'll need to fill in, as we'll describe below. Again, as before, you'll need to run this in the Android Studio project, compile it, and once the app is compiled, you can go ahead and run it in the Android Studio IDE, which will prompt you to select the appropriate emulator and allow you to run the app. When you implement the program, you'll have to modify several files. These files, as always, contain to-do, you fill in here tasks that you'll need to implement to provide a working solution. Please don't change the overall structure of the skeleton, just fill in the to-do tasks. In particular, if you take a look at the ReentrantLock hashmap simple semaphore folder, you'll find two files that you need to implement. The first file, which we'll look at in a minute, is called simplesemaphore.java. And you'll need to complete the various to-do tasks in the methods in this file to define a counting semaphore with fair semantics that's implemented using Java ReentrantLock and Java ConditionObject. There's also a second file called ReentrantLock hashmap simple semaphore manager.java. Once again, you need to complete the various to-do tasks to implement a Palantir manager using the simple semaphore that you implement in the previous file, together with a ReentrantLock and a hashmap. Grad students or students who are taking the class for grad credit have to implement certain methods in this file using Java 8 streams, as described below. Once you've built the various parts of the program and you copy over your implementation from Assignment 2A, namely the executor service portion, then you can go ahead and test your app. There's unit tests and instrumentation tests, and the instrumentation tests, when run properly, will indicate that your program is able to gaze at the various Palantiri without gazing for more than there are specified. And if things go well, you'll end up with a visual feedback showing a green title bar when you're done. If something goes wrong, you'll have a red title bar when you're done. There are some additional to-do tasks for graduate students. You'll need to implement the methods, some of the methods in the ReentrantLock hashmap simple semaphore manager.java file to use Java 8 streams. Undergrads are welcome to do this, but it's not required. As is always the case, the skeleton code for the assignment is available in my GitHub repository. You can go ahead and pull the code down and then complete the to-do tasks. The additional work required by grad students is clearly marked. This part of the assignment is designed to get you familiar with synchronizing multi-threaded programs using core Java synchronizers that are more powerful and efficient than the spin locks we covered in Assignment 1B. You don't need to program any Android-specific frameworks, but we'll be talking about these in upcoming assignments. Now that we've walked through the specification for Assignment 2B, let's take a look at the skeletons. As before, if you open the project, you'll find a number of folders. Some of the folders involve the tests you have to run, including the instrumentation tests and the JUnit tests. After you complete the skeletons, make sure you run those tests to ensure your program is working correctly. Let's go take a look at the skeletons. The first thing you'll need to do is copy over your solution to Assignment 2A which includes the responses to my comments I'll be giving you, and put them into the being callable and executor service manager classes. These are necessary in order to be able to have the program actually do the gazing threads. What you'll really be focusing on in assignment 2B, however, are the files that are in the ReentrantLock hash map simple semaphore folder. If you take a look there are two files, ReentrantLock hash map simple semaphore manager and simple semaphore. Let's take a look at the skeletons for simple semaphore first. If you take a look, you'll see that the purpose of this class is to define a counting semaphore with fair semantics that are implemented by using a Java ReentrantLock and a ConditionObject. There's a number of fields you have to fill in. You have to define a count of the number of available permits, and make sure that you look at this carefully. It has to have a certain type of type qualifier on the field, and make sure you think about that. And the goal here, of course, is to make sure that this field is not cached by threads. So you have to think through what that would be. We've talked about this earlier in the semester. You also have to define a ReentrantLock in order to protect critical sections of the simple semaphore methods. And then finally, you'll have to define a condition that's used to wait while the number of permits is 0. The default constructor is just there for the regression test. It doesn't do anything interesting. Here's the interesting constructor. This is the constructor used to initialize the fields with the count of the number of permits. So make sure that you implement the various fields and initialize them properly. Also make sure that when you do this that you set the ReentrantLock to have fair semantics. Take a look at the ReentrantLock videos to learn more what that means. The acquire method will be used to get one permit from the semaphore in a manner that can be interrupted. So you have to be able to handle interrupts properly. You also have to make sure that the lock is always released even if an exception occurs, such as an interrupted exception. So you have to put the logic in here using the ReentrantLock, the permit count, and the condition object in order to be able to do the acquisition properly. Here's another implementation you have to do. This is called acquire uninterruptedly. In this case, you have to make sure that the interrupt flag is properly handled. You have to make sure that the method itself is not going to be interrupted. So if an interrupt occurs, you have to catch the interrupt and then do some magic and then go back to try to get the semaphore again. So this will work even if there are interrupts that occur. This particular method is used, the release method is used to return one permit to the semaphore. And once again, you have to make sure that the lock is always released even if an exception occurs. And then the final method is called available permits. And in this case, you'll replace return 0 to return the current count of the number of permits. And if you are careful in how you define your field, then you don't have to do any synchronization here. This is a very good example of using the type qualifier that I was mentioning up here in order to avoid having to do any additional locking. Okay, so that's the skeleton for the simple semaphore. Let's go take a look at the ReentrantLock hash map simple semaphore manager. So this class is a Palantir manager. It extends Palantir manager, and it defines the mechanism that's used to mediate concurrent access to the fixed number of available Palantir that are going to be defined here. Internally, this class uses a hash map, the simple semaphore that you implemented in the other class, and a Java ReentrantLock in order to be able to mediate concurrent access to the Palantir. You'll, of course, have a hash map, as you've done before, that maps Palantir to a Boolean flag that keeps track of whether they're in use or not, whether they're available. You'll then have to define a counting semaphore using your counting semaphore class that you implemented. You'll have to define a ReentrantLock that's used to protect the critical sections involving the hash map. Some of the things are provided for you. We have a reset method that's provided. You'll have to implement a very simple accessor method that gets the semaphore. We use that later just to make it easier to refer to this without knowing the name of the field that you give it. Obviously, you have to replace return null with the actual field name. Here's the build model method. This is very similar to the one you've done previously. The main difference, of course, here is we're using a simple semaphore, not a semaphore. And so just have to keep that in mind. Take a look at the other implementations you've done to get a hint of how to do build model. Here's the acquire method. So this is going to use the simple semaphore to acquire it interruptibly, not uninterruptedly, but interruptibly. And then you'll find the first key in the hash map whose value is true, which indicates it's available for use. And you'll do this in a thread-safe manner by using the reentrant lock properly. Once you've found the appropriate key that's not going to be in use, the appropriate Palantir that's not currently in use, then you'll replace the value of the key in the map with a false value to indicate that this Palantir is no longer available, and you return that Palantir to the client. Undergrads can do this using a loop for each loop, for example. In contrast, the graduate students need to use a Java 8 stream. And in order to do that, you'll need to understand various parts of Java 8 streams. I went over some of this a little bit in the frequently made mistakes for assignment. I will go over this in the frequently made mistakes for some of the previous assignments. So take a look and see how you can do that there. Undergrads are free to use a Java 8 stream, but you're not required to do it. So that's basically the acquire method. Make sure again that if there's an exception that occurs, that you always release the reentrant lock properly. So get in the habit of using the try finally blocks to do that. Another method you'll need to implement is the release method. This, of course, just as before, is going to put the true value back into the hash map for the Palantir key. It's given as a parameter. Naturally, this has to be done in a thread-safe manner, so make sure you use the reentrant lock properly. And if all goes well, then you need to release the simple semaphore so that another being will have a chance to acquire the Palantir and gaze. Here's the available permits method. You can see we just use the get semaphore accessor and available permits to return the number of available permits. This is not used in the assignment proper, but it is simply used in the regression tests. So I provided the implementation for you. So those are basically the parts of the skeleton that you'll have to be focusing on. The main issue here is learning how to use reentrant lock properly with try finally, and of course implementing simple semaphore. And if you're a graduate student, then learning how to do some of the various operations using Java 8 streams. So that's a more sophisticated way of doing things. Okay, so I think that is essentially the summary here. And make sure when you're done, you run the various tests in order to ensure that your program is working properly.